Alright, so I'm assuming you've read this problem before starting the video. If you want to know this, I would just say to see your class notes. That would be the stuff that says day 2, alright, or look in the book. So, blah 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 blah, what is the optimal planting strategy? AKA, how much of each crop? So that tells us right away that X equals the number of acres of crop 1, and Y has to equal the number of acres of crop 2. So those are what our variables stand for. What is the maximum revenue produced from the planting? So the maximum revenue, that's going to give us our max-min function. So I always use the f of xy. It's P equals, P equals f of xy equals, doesn't matter which way you name it. It says there's a $40 net revenue on crop 1, and then a $60 net revenue on crop 2. So that's $40 per every crop of crop 1, acre of crop 1, plus $60 for every acre of crop 2. So here's our max-min function. Alright, now let's come up with our constraints. One constraint would be the labor. So remember, when making your system, you look for totals. First of all, just think of equaling the totals, then you can worry about whether it needs to be more or less. So one of our totals is going to be labor. So where do we see our labor? Our labor is crop 1 requires 1 man day of labor, and then crop 2 requires 4 man days. Alright, so that gives us our first constraint. So 1 man day times number of crops of crop 1 plus 4 man days times number of crops of crop 2 equals, how much does he have total available? 320 man days available. So that means that we have, if it was exactly equal, it would be 320. We want less than or equal to 320 because the maximum available is 320. Alright, our next constraint is going to be the capital. Alright, so the capital is $10 for, this gives me a blue here, cool. $10 for capital, oh wait, no, where is it? 10 for each, oh that's awful, sorry about that. $10 of capital for crop 1 and $20 capital for crop 2. So what we're going to do is say that it's $10 times every crop 1 plus 20 times the number of crops 2 has to be less than or equal to $220. We can simplify this. I'm going to do that right now actually. I can divide this whole thing by 10. So that's going to give me x plus 2y is less than or equal to 220. Okay. You can do it now or you can do it later when you're solving your system of equations. Either way. You also want to do x is greater than or equal to 0, y is greater than or equal to 0, and our last constraint would be that he owns a 200-acre farm. So number of acres of crop 1, number of acres of crop 2 has to add up to less than or equal to 200 acres, right? You can't plant 220 acres if you only own a 200-acre farm. So we're going to
Kayla Allard, please report to the main doors. Kayla Allard to the main doors.
Copy that over to here so I can graph all these guys for you. I didn't give them a number code yet because I used the colors, but I am going to do that now. I first just want to clean this up a bit. Oops, that was capital, whatever. So, we'll There we go. This was capital. And this I'm going to call area, total area of land that he has. So now this is going to be our equation 1, 2, 3, and then you just remember that we're only using positive values. So I'll just right away say that we're only using positive xy values. So we're only going to be in the first quadrant. Alright, so these are all in standard form, so I'm going to get the intercepts for all of them. So for equation 1, we have if x is 0, then 4y equals 320, so y is 80. If y is 0, cover that up, and x equals 320. Alright, so I'm going to do all the intercepts before I start making my graph so that I can see what I need to scale it by. If I end up scaling it by something different than you already scaled it by, that's fine. Just try to think about the dilation, the stretch, or the shrink in here, comparing yours to mine. So these intercepts are going to be, if x is 0, we have 2y equals 220, so y is 110. If y is 0, then x is just 220. 20, oh, come on. There we go. And then this is going to give us intercepts of x is 0, y is 200. If y is 0, x is 200. So let's graph these. Equation 1. Alright, so we need to fit 320 on our x-axis and at least 200 on our y-axis. So what I'm going to do is go by 20s. Each box is 20 here. So I'm not going to label every box, and it actually works out just great so that all the intercepts work out good. So I'm going to pause this and finish it, so it should appear in a second. Alright, so I chose a scale of 10 on my y-axis. My first intercept is 0, 80, and 320, 0. So now I draw that line. And I can't assume necessarily that these lines are going to meet where I want them to, so we'll have to check that after. The next line would be the labor, or the capital rather. That's 0, 110, which is going to be right here. And then 220, 0. Now I do my line. And then that looks like that meets exactly there. And actually it does. You could do a system of equations between these two, which I did when I was making my answer key. So if you look at the PDF of my answer key, you're going to see that I found the intersection of these algebraically and found that it is indeed 120, 50. That's where those meet. Again, I forgot to shade, but going back and checking through my color code or through your number code, equation 2 is 0 plus 0 less than 120. Yes, that's going to shade towards the origin. Is 0 plus 0 less than 320. Yes, that shades towards the origin. We include the origin because that worked. Alright, so I got one more. I got 200 here and 200 here. Draw my line. And I can try and be super careful, but I shouldn't really trust myself. If you do find the slope of this line, you know the slope is -1. So going from here to there is actually down 20. From this point it's down 20 and forward 20. Alright, I use different scales on my x and y, that's why it looks rectangular, not like a square, but down 20 over 20. So that's a slope of -1, which is what the slope should have. Or you could just do a system of equations and check to see that it does in fact meet on the point that it looks like it meets on. It does get shaded inside here, so our feasible region is going to be along here. So this is our feasible region in here. All right, those are all the possible points. Our vertices of our feasible region are going to be 120, 50. You can find the intersection of these two. It's going to be important later, so I'll just write it now. It is 160, 40. It does not matter for this, but it matters for the sensitivity analysis. And then I'm going to find these are 180, 20. And then we also include 0, 80, and this intercept, which is 200, 0, because they're on the edge of the feasible region. Technically 0, 0 is also 1, but certainly planting 0 crops is not going to give us our optimal profit. So I go back up here. What was my profit function? It was this. So I'm going to use that here, and again find the values. So I'm going to plug in each of my points. So we got 0, 80, and that's going to give me, plug that in, 40 times 0 is 0, plus 80 times 60 is 4,800, so 4,800. And then our other points, 120, 50 gives us 4,800 plus 3 grand, which is 7,800. Our other point is, this one's not on the edge of the feasible region, so we don't care about that for right now. 180, 20, and we plug that in and we get 7,200 plus 1,200, which is 8,400. And then our last point, 200, 0, we get 8,000 plus 0 equals 8,000. So our optimal point is this. So the max profit equals $8,400, and then that occurs when we have 180 acres of crop 1 and 20 acres of crop 2. So that is answering the question that was being asked. Alright, so the next video will be the sensitivity analysis.